Okay, in this next problem we have BC 2010, number 5. Consider the differential equation dy dx is equal to 1 minus y. And let y equals f of x be the particular solution to this differential equation with the initial condition f of 1 is equal to 0. And for this solution, f of x is less than 1 for all values of x. So the first thing that we want to do is to use Euler's method, starting with x equals 1, to approximate f of 0. So we're going to have our x, our y, our delta x. In this case, we're not given delta x. We're starting at 1, and in 2 steps of equal size, we want to get to x equals 0. And so we're starting with 1, x is 1, y is 0, and our delta x is going to be negative 0.5 or negative 1/2 here. Our y prime is 1 minus y, so in this case it's just 1, and our y prime times delta x would be negative 0.5. Our new x is 0.5. 1 minus 0.5 is 0.5, and our new y would be 0 minus 0 plus negative 0.5. And so y plus delta y is equal to negative 0.5. So we're ready to go again with our new x being 0.5, our new y being negative 0.5, delta x is still negative 0.5, and our y prime is 1 minus y, so that would be 1 minus negative 0.5, which would be 1.5 positive, and the y prime times delta x would be 0.5 times 1.5, negative 0.5 times 1.5 would be negative 0.75, and we're ready to construct the new x value, which would be 0.5 plus negative 0.5 is 0. The new y value would be negative 0.5 plus negative 0.75, which would be negative 1.25, and so that would be our answer there. I will go on to part B. In part B, we have the limit as x approaches 1 of f of x over x cubed minus 1. And with any limit, we want to try to first plug in. When we plug in 1 into f of x, we're going to get 0 based on the initial condition that we're given. We plug in 1 into the denominator, and we're also going to get 0. So we can use L'Hopital's rule here, since we have an indeterminate form, 0 over 0. And so that will be the limit as x approaches 1 of f prime of x over 3x squared. Now, the limit as x approaches 1 of f prime of x, well, that's simply limit as x approaches 1 of 1 minus y over 3x squared. And as x approaches 1, again, the initial condition was that y approaches 0. And so we end up with 0 over 3 times 1 squared, which would be 3, which is 0. And so that would be our answer for part B. Now in part C, we want to find the particular solution to the differential equation dy dx is equal to 1 minus y. We're going to use separation of variables here. So we get 1 over 1 minus y dy dx is equal to 1. Integrate both sides with respect to x. The dx's cancel. We get 1 over 1 minus y dy is equal to integral dx. Integrate both sides. Get the natural log of the absolute value of 1 minus y is equal to x plus c. And exponentiating both sides, we get absolute value of 1 minus y is equal to e to the x plus c. And rewriting the e to the x plus c as e to the c times e to the x. Getting rid of the absolute values, I get 1 minus y is equal to plus or minus e to the c e to the x. Plus or minus e to the c, all can come out as one constant. We get 1 minus y is equal to c e to the x. And adding the y to the one side, moving the others over, we're going to get y is equal to 1 minus c e to the x. At this point, we can use the initial condition that x is 1 and y is 0. So when x is 1, y is 0, and we would end up with c times e is equal to 1, so that c is equal to 1 over e, or e to the negative first. Plugging back in, we get y is equal to 1 minus e to the negative 1, e to the x. And we get 1 minus e to the x minus 1. And so that is our final value for y. Y equals 1 minus e to the x minus 1. And so that will do it for parts A. For part B, and for part C of this problem.